KPMG, CBS, DTU, Skylab, and Defudger seminar or webinar on deepfakes. First of all, I just want to let you know that this is we are going to record this session, so please be aware of that. And after that, I can say that I'm very happy to be here today, joining you from a galaxy far away. And let's see if we can get it to the next slide here. So you can say actually my real identity is not Han Solo. It's actually Michael Jensen. I'm a director at KPMG Newtech here in Denmark, and I'm working with basically a number of different AI technologies and leveraging them across industries, and been doing that for the past 10 years. And being a company that is deeply into AI, also using AI in a good manner is something that is very important to us, and that's why that we are keen to put the topic that we are discussing today on the agenda. But our speakers today, just to set the scene, we will start by giving you a brief introduction to what we are seeing in the computational propaganda space, where deepfakes is one of the technologies that is being applied. And thereafter, we'll go into a presentation by Defudger, and that is then followed by a short Q&A session. But the other speakers today, I would like to briefly let them introduce themselves. So, Signe, will you introduce yourself?
Somebody is, yeah, thank you. I just needed to be unmuted, and unfortunately, I haven't got a nice Princess Leia version that I could deepfake myself with. But I have been researching in AI during my PhD 10 years ago, and then a lot of things has happened within AI since then, and now I'm doing a postdoc in AI as well at the Copenhagen Business School, and I have done public speaking and teaching kids and adults how to code and so on. So I have a general computer science interest as well as a specific AI focus, of course. Yeah.
Perfect. Thank you very much, Signe. And then the Defudger team, would you mind introducing yourselves? I can see that you are muted up.
All right, it's working. Can you hear me?
Yes.
Perfect. Let me try it here. So my name is Christoph. I'm the CEO and co-founder of Defudger. And I have my two other co-founders, Zoltan and Dominic, here.
Hello, my name is Dominic. I'm a CEO of Defudger and also responsible for the product development and the organization of our startup. And we also have Zoltan here.
Hi, I'm Zoltan, the CTO and the co-founder of Defudger. And me and Dominic, we are from the Technical University of Denmark, DTU, where we are studying and focusing on AI and computer vision.
Perfect. Thank you very much for joining today. So we will just start out before we hear from Defudger. We just would like to sort of briefly set the scene. So when we are talking about computational propaganda, what are we then actually talking about? So let me just again change here. Just to set the scene. I think what is key when we're talking about computational propaganda, what we are talking about is actually a number of different kinds of technologies. So it's a sort of an ill will, purposely or purpose to actually distribute misleading information, for example, over social media networks. And this information can take various formats. So one is a video. That's what we were seeing before with the based avatar on Han Solo. We could have put in any image there, any politician, whatever we want. So we are seeing a lot. We are seeing videos being manipulated. We are seeing traditional images being manipulated. Also seeing text and articles being manipulated. So basically algorithms that are writing up articles that are more or less whereas more or less it's not possible to actually tell that this is fake, but it actually is. So it's a very sort of dangerous stuff. And then last but not least, we're also seeing voices being manipulated, so that you can, based on a little bit, or maybe not a little bit, quite some hours of voice recordings, you are able to basically sort of create a digital version of that voice and start using it for your own purposes, and those can definitely be malicious. So that was just to set the scene. And I think what is important to be aware of when we are talking about sort of manipulation online, we're seeing that this is a challenge that is escalating. So one of the organizations who are following this space is Oxford. So there is this I think it's the Computational Propaganda Group, something like that, that is continuously following the use of misinformation online, and what they're seeing is there's quite a continuous significant increase in the number of countries that are using organized social media manipulation over the last years. And I think when we dive a little bit deeper into it, what is also interesting is that this is being used both internally. So we are seeing governments using sort of computational propaganda manipulation on their own publics to manipulate own public or shape own public opinion. And so far, I think they were saying that about 26 countries that they've studied are actually using computational propaganda as a tool to manipulate or influence their populations. So that's the internal part, and it's also being used externally. So I think that's some of the cases that are quite that have gotten quite a lot of traction in the press, where we are seeing countries trying to influence elections in other countries and those kind of things. So it is an issue that is rising in importance, and is something that is where it's key to actually do something about it and manage it. Before we actually go into the Defudger presentation, where Defudger will dive into, okay, how can we then actually try and combat this issue of manipulations, in particularly focusing on images. I just wanted to mention that deepfakes are varying in complexity. So many times, we were thinking about, okay, it's for example the Han Solo avatar being used to do something rather complex, looking like a statesman on TV and manipulating that. However, it actually doesn't take a lot of skill. There's software out there that is more or less readily available to use, but it does require compute power and that kind of stuff to get working. But you can get quite strong impact without taking these advanced tools into use. So what we see here is just a simple manipulated image where suddenly a soldier is sort of declaring his allegiance or at least collaboration, making his collaboration very clear with the US, and on the right side you have the original image, and if you notice there's no insignia on his sleeve, and then on the left side you have this manipulated image. Suddenly he's wearing the Ukrainian colors, and and that is and the image is then used to create a negative campaign towards both the US and Ukraine. And I think it's it's interesting how rather simple tools can create quite a lot of impacts. So just to sum up sort of the introduction, there's a number of different tools that are being used to do this computational propaganda manipulation, everything from video to voice to articles to so text. It's increasing in use, so it's becoming more and more popular to use these kinds of tools, and you can actually create quite an impact with very simple tools. But the good thing, though, is that there are people who are working to handle this situation, and one of the companies that are out there is Defudger. And so I think without further introduction and ado, I would like to invite the Defudger team to present their screen, and then give us an introduction to their technology, and thereafter we can then dive into the Q&A. But Christoph and company, the screen is yours.
I believe Zoltan is going to share his screen with the presentation. There we go.
Yes. Hello, thank you for the introduction. Can you see my screen?
Yes.
So thank you for the introduction. And what Michael has said is really important to understand how the different manipulation types can be of from so many diverse fields, and they can be of different complexities. And I would also like to start with a little bit of introduction, what deepfakes are in general, then move on to how to create them and how to detect them. And I promise I will try not to go that much into the details for the non-technical people. And then finally, I will touch upon how the different industries are affected by this technology and what they can do to evade the threats before we head on to the Q&A session. So let's start. That fake news are not a recent phenomenon. I think everybody remembers how big of a trouble it was in 2016 in the US elections, when everybody was talking about fake news and how much fake news can affect the results of such an important event in the world. And it's not a recent phenomenon, but what's new is that by now the computational tools and also the AI-powered algorithms have reached a sophistication level that now it's possible to use these tools to automate the generation of fake news, and also to create ever better modified content, and they are increasingly better to convince people. And this is coupled with the spread of social media, that everybody is always connected, and within just a couple of minutes or hours, people can share it and it can reach millions of people. And there's still this ambiguity regarding the naming of deepfakes, that even in the research field and the popular culture, deepfake is used as a buzzword, and it is used to describe many different things. And Michael has already said that it can cover images. For example, I think many of you have seen the images coming from NVIDIA's lab, that they created human-looking portraits from scratch just with the machine. And then the audio files, there was an accident last year when a person got a phone call from their CEO who was saying to transfer this amount of money right now to that account. And everything matched. It was the phone number of the CEO, it was his voice, but then it turned out that it was just a fraud. Somebody hacked the system, and then they used this voice model to social engineer the fraud. And then probably the most famous form of deepfakes are the videos, where we differentiate between different techniques, such as face swaps, deep video portraits, and full body puppetry. I will go into more details about that a bit later. And talking about the the creation techniques, all of these are based on generative models, deep learning models. And on the left-hand side, you can see an example of how an autoencoder, a special deep learning framework, can be used to create face swaps. So the idea behind the face swap is that we want to replace actor A's face with actor B's face. It's much like the famous face swap filters in different phone applications. And an autoencoder is a framework that's made up of two parts, an encoder and a decoder. And the encoder is responsible for compressing the input image. So you can see that the input image is compressed into a much simpler representation that maybe only contains the facial expressions, the hairstyle, but not the texture. And then the decoder is used to go back from the simple representation to the original image as close as possible. And through training, these encoder decoders can become so perfect that they will be able to compress and then decompress the images without basically any visible losses. And once this is done for two people, then it's possible to swap their decoders. So use the encoder of the source and the decoder of the target person to kind of like build up of the target's face using the expressions of the source. So what's the result? You can see here that the resulting picture has the facial expressions of the target, but the actual texture of the source. And on the right-hand side, you can see another type. This is what we call the deep video portrait. Here, the biggest difference is that we don't actually swap the faces. We don't exchange the faces. We only use the target video to be the driving video. So we track some key points on the face. We follow how they move along the video and use them to change the facial expressions of the source image. And then here in this example, my face acted as the driving video. I was doing different facial expressions, and we had 3 source images, 1 from me and 2 from Dominic, my other co-founder. And you can see how well the facial expressions are transferred. And you can see that this is even more dangerous than the previous one, because this way we can make people say whatever we want them to say, because their facial expression will just follow along those words. And then you might think that this is really complicated, and how can it become such a widespread problem when it's not easy to understand how does it work, and it's also kind of a black box method. But the thing is that much of the development is coming from the community, the open source community. 2 of the most famous deepfake creation tools are freely available on GitHub, and they are among the most popular repositories on GitHub. So anybody can just go there, they can download the source code. There are lots of forums where people can ask their questions and others will help. And there have been some examples when some other peoples or companies have even created user-friendly apps. And probably the most infamous one is a Chinese app called Zao. You can see it on the right-hand side. They introduced it last year, and many people downloaded it because it was fun. You can put your face into any famous movie clips, and who wouldn't want to be, I don't know, Han Solo from Star Wars. But after a few weeks, it turned out that when people clicked on the terms and conditions, they accepted that the company will store their facial landmarks. So it was a big scandal at the time, so people deleted the app. But you can see that this is going easier and easier to create, and they will become a lot more widespread, and they will be shared on the social media. And then comes our part. What can we do about it? And Defudger is a Danish startup. We started 1.5 years ago with the ambition to stop deepfakes from spreading and stop them from manipulating people. And we like to say that this is more like a cat and mouse game, just like the antivirus and the virus creators, that there are 2 sides, the creators and the detectors. And one moment maybe the creators are one step ahead, but then the detectors need to innovate. They need to come up with better models to detect the forgeries. And then maybe the creators, just in a few months, they will come up with better and better solutions. So there's no final solution. It's going to be an ongoing struggle. And lately, there has been a big push on the detection side due to the Kaggle Deepfake Detection Challenge, which has been initiated by Facebook, Microsoft, the partnership of AI, and I think Amazon, and they pledged $10 million to create the biggest deepfake dataset in the world that contains 100,000 videos. And this is super important because for any AI application, it's a must to have a lot of data. Because once we have data, we can build up models that will be able to detect learn the patterns and detect the fake videos. And what we do at Defudger, we not only focus on videos, but we also do image detection. This is a little bit more simple, but as of now, as of 2020, manipulated images are a bigger problem than deepfake videos. And since manipulations can be of so many different types, we have to have separate models to detect different types of manipulations. So for example, you can see that we have a metadata analysis that only checks the metadata of the incoming image, and then it looks for explicit manipulations. And then we have a reverse image search module that looks for the copies of the same image everywhere in the web, and we might be able to track down that the same image has been shared maybe 5 years ago. Then this is not authentic, and maybe people are reusing it for different purposes. And this way we can filter out shallow fakes, so-called shallow fakes, that are images or videos that nothing is wrong with them, but they are just taken out of context and they are reused in new scenarios, and they are used to mislead people. And then we have the more interesting algorithms on the bottom, marked with the blue, that are based on AI technology, where we are looking for signs that might not be visible for the human eye. So the noise consistency module checks if every single part of the image is consistent with the others. You can imagine that if two people take two photos with two different cameras in two different scenarios, then they crop one part of image A and paste it into image B, then there will be some noise inconsistencies that are not visible for the human eye, but once we do the statistical analysis on the image, we will be able to detect them. And then similarly, we have a JPEG quantization algorithm that checks if some parts of the image have been compressed with the JPEG algorithm more than once. And we have just a general pixel consistency that's a self-supervised deep learning algorithm. And not to have 6 or 7 different results, we use an ensembling method on top to combine their individual results and come up with an overall short prediction, just a percentage was the fakeness probability or not. So in the end, an image enters our system, then we do all these 5 algorithms parallel to each other, then we do the ensembling on top of them, and then just output a probability of fakeness. Moving on to the videos, we do something similar, where we use 3 different deep learning models to extract features from the video. We do a per frame image, per frame deep fake detection, to say that. So we split the incoming video to individual frames, and then we do the detection on them. And these models can detect leftover artifacts, because these manipulations are not perfect as of now. For example, it's possible that when a face is pasted on top of another face, there will be some leftover artifacts along the cropping. So maybe somebody is going to have 2 chins or 2 mouths and other artifacts like that. And with these 3 algorithms, we are able to extract features, and then we do the classification on top and do the prediction. And here is an example of our results. As you can see, we do the per frame classification. So for each frame, we have a prediction if the face is real or fake. And we mark the fakes with the red, and we mark the reals with the green. So talking about what industries is it relevant for? So far, we've been developing our solution, working closely with the news media, because we believe that that's where they are the most relevant and the most obvious. If a credible news agency shares a story that contains fake information, a lot of people will believe it, and then it will have detrimental effects. Moreover, platforms are also prone to this problem because they deal with a lot of user-generated content every day, and they are responsible for the acts of their users. So Facebook can be fined in Europe if they spread misinformation, even though it was their users who actually put up the misinformation. So Facebook has to be sure that they take down everything that's not relevant. And then in the insurance industry, fraud is a really big topic. They lose a lot of money on fraud. So what we can do is that we can build up a system where the incoming images or videos are checked and they are labeled as fake. And then this way, the bad actors will not be able to get their false claims through. And similarly, in the KYC industry, as people nowadays are more likely, or more often, they need to identify themselves without being present in person. They just need to take a photo of their ID card or themselves, and there's an obvious threat there when people would reuse other people's photos or just generated content. In the legal industry, the interesting thing is that images and videos have always been considered to be evidence. But how can we actually be sure that they are not forged? And to figure that out, they need to resort to algorithms, as people are not going to be able to see with their own eyes when something is original or not. And then, of course, deepfakes can be a new form of cybersecurity, because they can enhance the social engineering that goes behind when somebody wants to trick others. And we also listed e-commerce because they deal with user-generated content. People put up images and videos of what they want to sell, and they should be verified to be original and authentic. And as the problem is widespread across many different industries, of course, there is not one single solution that's going to fit all of them. So that's why Defudger offers two types of products. One is a web application, and the other one is an API. And the web application can be used on demand. So whenever somebody receives an image or a video that they want to check, they can just drag and drop it, and we will do the analysis, and then they get the results within a couple of minutes. On the other hand, the API can be integrated to any digital platform, and then it will do all the analysis behind the hood, under the hood, and the moderator will only get an alert whenever we find some misleading content. And here you can see a screenshot from the first version of our web application, where you can see that this is the uploaded image with Putin sitting at the table talking to his ministers, and then he's wearing this protective suit. And with our algorithms, we have detected that this has been modified, and we show this heat map that contains the modified region. And then we have some of the results from our individual algorithms, such as the metadata analysis, the reverse image search, and the computer vision analysis. And so far, we've been working together with some of the biggest German media companies, and they have trusted our system, and it's really interesting to see where we are gonna go. And we have a lot of partners across Europe, and we are proud to be part of Skylab because they have helped us a lot. And that was our part of the presentation.
Perfect. Thank you very much, Sultan. Very cool stuff. So while I jump onto the other slide, maybe Signe, will you start us off on the Q&A?
Sure, always. Yeah, thank you very much. I think it was great, and of course I have heard about your technology before this all started, and I love that also Mikael started with the Han Solo thing, because what I thought of was actually the Harrison Ford in the Blade Runner, where he is fighting evil AI and figuring out in the end maybe he is himself an AI. So this is this AI fighting AI in this cat and mouse race. I think it's so interesting, and it's great to have this focus on it, because people are really losing trust in a lot of things when they figure out more and more is fake, and how can we actually detect it. And that leads me also to this, what is the drivers of both those who are creating deepfake, but also those who are trying to debunk it, or to reveal the fakes. Maybe Defudger can answer, and maybe also Mikael has some suggestions for this.
Maybe I can have a few initial answers to your question, if you can hear me clearly.
Yes.
So the drivers for the creators can range from fun, activities for entertaining their friends. There exist several of these applications where you can create some GIFs, and there has been also some innovation there where you can use artificial intelligence to kind of personalize your GIFs to your friends. So most of these driving forces behind the creation of these deepfakes will be in the future for entertainment, and that's how it goes, because let's assume that most of the people will not use it for destroying the society of trust, let's say that. But inevitably there will be use cases where this can be used for manipulation, like there has been several examples. For example, in Africa, they use it to defake a politician, and also in Bangladesh. So there has been already some political manipulations here and there. Fortunately, they are not that frequent, and we don't know the answer why people are not, starting to create these defects more and more. But we suppose that with the availability of these tools and the methods, they are going to be easier and faster to create. These use cases will be much larger, and there will be more deepfakes which will be malicious. But these are the major use cases. And also for professional causes, you can use this deepfake technology. Let's assume that you want to make a movie and your actor is injured, and you want to replace the face of the person, of the actor who is not at the scene, with the guy who is playing the static role of the actor. So in Hollywood, there is a totally nice availability for this technology. We assume that it's going to happen in the next few years. In China, it's already happening. They replace one of the actor's face with someone else because of some scandal, and they use deepfake technology. So this is really exciting for the entertainment industry overall.
Yeah, it's fun because I've been teaching kids in the programming, and I also heard from them that's one of the things they just love. That's this deepfake creation. So and it can be powerful, as you have mentioned, in the wrong hands, or in the hands of somebody who is just playing. So I really like that so many media industries are actually interested in being part of discovering this. How quickly can your API run? I mean, can you, for example, YouTube is creating, I just looked it up, 5 hours of video or people on YouTube are creating 5 hours of video every second, and how quickly can you actually figure out if things are fake or not? Is it long?
Yeah, that's a great question, because what we should know about these techniques is their scalability, because that's always the issue. But Luckily, there is a large improvement. Like, for example, a year ago, one of the most famous deepfake detectors, like for a high quality video, it ran in 7 minutes, which is an incredibly long time. But with improvements and the community as a whole trying to figure this out with this Scalability challenge, there has been several methods which reduce this time to like 5 or 10 seconds, because there are a lot of other directions what people are trying to do here in this field. And with that knowledge, what we gather from there, we can easily figure out what is the best one in terms of scalability and runtime issues. And of course, a product which is in an operational environment that should be fully scalable and working. So what we see as of now, one of the state-of-the-art methods can run in 5 seconds, which is pretty awesome compared to what we had a year ago, for example.
Yeah, actually, one of the questions here is also, how does your detector deal with the change of compression or images of images, i.e. if video compressed and uploaded, or a photo of an image? Okay, that was not completely into this, but maybe you can answer that. So it's a rather technical one. If there is a change of images, should I try to read it up again? Or can you see
No, we got a question. I see the question.
Yeah.
So maybe I can answer it. And
Great.
Actually, this is one of our biggest problems right now, that if the image or the video has been compressed a lot of times, we just lose so much of the information that it becomes impossible to detect. So what we do is that we have this reverse image search module that we try to get back the original version of the image. And that way we can kind of circumvent it. But if they are not available, then as of now, it's impossible to tell some of those highly compressed videos apart from real ones. But on the other hand, it should be the person's judgment in the end who wants to use that video as an evidence. If it really has a low resolution, then, and also the detector methods say that they have no information about it, then maybe it's not a trusted source.
Yeah. So there is another question here, because we saw one of your slides where you had a lot of different sources going into a common percentage of whether this should be fake or not. And one is asking if Defudger also has a separate voice module for revealing deepfakes.
May I answer this question? So we put a lot of effort into audio detection and audio manipulation at the same time. We've been working on this for a few months now, and we can see that audio manipulation is a little bit easier problem than with these videos. But at the same time, since we are startup, we had to stop our research there, because we would like to focus on solely photos and videos as of now. But voice detection is surely a thing afterwards, once we have the resources and also the possible opportunities where we could use it for.
Yeah. Okay, thank you. So there is I have one question here that I've been thinking of, because I have been a lot on Twitter and other places the last couple of months, and there is a lot of things and a lot of information going on the corona crisis and the coronavirus and so on. And I wonder if there are, if countries or companies has used this somehow. I mean, if we can see that the deepfake is used in a crisis like this. Do you know anything of that? I mean, we've heard a lot about, for example, Michael showed propaganda from Russia on a picture, and we know China is very big on AI. So have they used deepfake for any of the information going on right now in all this corona debate? And because it's quite difficult for many people to find out what is right and what is wrong. Do you know anything of that? I mean, it's also maybe it's not the core of your business, but I was just curious.
Yeah, so of course we have seen some manipulations, but mainly they were from the more simple types. So the one that we call shallow fakes, when the image is taken out of context and then they are reused. And I could mention some examples that there was this famous photo when people were lying down on the ground, and it has been reshared many, many times on Facebook, saying that this picture is taken in Italy, in the epicenter of the virus, even though the image is from 5 years ago, which was just a flash mob done in Germany.
Okay.
And the thing is that it doesn't matter for the people, because you see it, you believe it, and then maybe after 5 days, you get a remark from one of the news articles that it was actually fake. It already had a detrimental effect of causing chaos. And in times of crises, it's even more important that we are not misled, because now people's lives can depend on having the right information or not.
Yeah. Like, then we can't do anything about presidents saying that we should eat dangerous medicine and stuff like that.
Exactly. Then we don't need deepfakes if you have presidents like that.
Yeah. So I got another question here. I read it up. Do the inferences of your software definitely detect a deepfake, or should they be considered just as one of several factors for a human decision maker to take into account when making a determination? So I presume that's when you have like a 70% outcome or something.
So that's a really interesting question, what we face, let's say, daily. It entirely depends on the use case. Let's assume that you use this for content moderation on a social media platform. Maybe it's not mandatory that there are, maybe it's not that crucial that there are some false positives there. Let's say that you could remove like 100 deepfakes manually there, but with our system, maybe you can do like 500 or even more, of course. But of course, with false positives, then we think that's totally fine. There doesn't necessarily have to be a human decision maker there, but of course it's always better to filter out those false positives. But for example, in use cases like media or law, where it's really important that these algorithms are precise and as trustworthy as possible, we always say that there has to be a human in the end of the loop. There has to be a human which decides what is this result about, because it's machine learning. Machine learning algorithms are never going to be 100%. They will always have to be authorized by someone that this is actually true or false. Like when we talk about image manipulation, it's really something that we can only help by aggregating the data, and the journalists are using the data to make the final decision. The technology is not there that we can just have a binary output like this is fake and this is real. That's a really, really hard thing to accomplish, and we don't think it's gonna be reality in the near future. Hopefully later on, but we will see how.
Yeah, and then the journalist should know enough about statistics that if it says like 70% or 60%, well, then we are going to do a bit more research on it before defining if we should trust the media or not.
And that's also a question how you want to present your results, because if you want to present them in the most accurate way, then of course you would have to spit out those nasty statistic results in mathematics, but those journalists are not going to understand it. So you have to do kind of a dimensional reduction of the result there. But with that, of course, it's not that easy to keep the original meaning of it. So that's what we are facing as a challenge, and we are trying to optimize it. But luckily, what we see now is that in the media, journalists are pretty aware of what's going on in the world of big data, and also how they can educate themselves to counter and to know about all these methods. So hopefully, in the long run, we can work something together and have the best optimized solution for this problem.
Yeah. Yeah, because it has for many years been an issue that journalists should know statistics, but it becomes more urgent now, perhaps. So
I would say it's pretty urgent now, and I also saw that some journalists even learn how to code in Python, which I was amazed. Like, wow.
Yeah. So I'm just a bit curious because I know there has been talk. So this is one of my own questions. Sorry, you have posed questions, because they quite often when using AIs and public data, or then there is biases. For example, racial biases or gender biases, such that it's easier to recognize a man than a woman and a white than a colored person. Do you know if there is anything of that in? Or there probably is, but do you know how big the problem is in big fake and also in Defudger's tool? If there are,
maybe I can start answering this question. I have a very small input here. We haven't faced any racial bias statistically or with our analysis yet, but it's confirmed that it exists even with deepfake detection tools. Like there are these very nice conference videos about Professor Hani Farid, who is a very nice and big name in the field of deepfakes. And he has confirmed in his research that there exists some racial bias here. So it's let's say that it can be considered as a typical machine learning problem for this classification of either content. But I would say that even raises the need for someone to authorize or to double check these results. So there has to be a human in the end who checks the validity of this. There shouldn't be an algorithm which decides about someone's fate on the jury or in the courthouse, what's going to be the fate of that person. So I don't think that should be allowed for a single algorithm to do so. And one thing which we want to spread is the research direction into this so-called explainable AI. Because right now, what we have as AI is this typical black box scenario where you have a machine learning algorithm and you input the data and you get something as output. And even the people who make these algorithms, these artificial neural networks, they don't really know what's happening inside there. Of course, there are some cases where people do this really nice visualizations, what's happening, but there has to be a larger effort into discovering these. So I think explainable AI should be a research direction in this field for sure. So we can deduct why the algorithm made this decision, not just, okay, the algorithm made this decision.
No, I think in the beginning it can be nice just to have something that can screen the stuff, but it's already there. It was there a bit in your tool, for example, the picture of Putin, where it could highlight at least what was what you call peeking out on the picture. So yeah, so I think you have. So I'm trying to take. I'll take the next question here.
Excuse me, I would like to add something to this previous question regarding the gender bias, gender and racial bias, because I think it's very interesting to note that even though when it comes to deepfakes, everybody talks about political scandals and economical problems, and that might be a problem of the future. But what's really a problem of today is that according to Deeptrace, another Dutch startup fighting deepfakes, they made the research, and according to them, 95% of all the deepfakes online are non-consensual porn videos. And that means that they are, of course, mainly targeting female actors and famous female people that non-consensually, they just take their photos and then they paste them into porn videos. So that's very interesting to see.
Yeah, that sounds that's so interesting.
No, not so interesting.
No. Yeah.
Sina, I think that we should more or less begin to wrap it up a little bit. But I would just like to sort of begin closing it down with looking a little bit ahead. And there's a question in the chat saying, where do you see this moving in the future? So how big will the issue be? And then if you take that with first, and then I would like to add another angle on it. So I think I'm probably not the only one who has been spending more and more time in VR over this COVID-19 situation, and with VR becoming more and more sort of developed and everywhere, and we're seeing AR glasses arriving. How do you see this? This problem of deep fakes when we're suddenly very much interacting in a sort of software-based or at least software-enhanced environment. I'm not really sure if my question is clear, but when we're suddenly in AR or VR, how will we then, how can we protect ourselves there? What should we be aware of when we're suddenly in a software world when you're thinking deepfakes? But first, maybe take a little bit of a shorter view and say how do you view this in the short run, and then maybe how do you view it in the long run? And I'm not sure if any of you guys have an answer for that.
So personally, we don't really have any experiences with VR and deepfakes and the combination of the two. But what you said is definitely true, that people are moving more forward to living a bigger portion of their lives online and using more and more softwares in their daily lives. And as you said, this will just make it even more clear that authenticity is gonna become a very important topic, and how can we trust what we see, because so far it has been considered to be evidence, but not in the future.
Check. All right, I think that we are more or less at the end of the session now. So, but before we close it off, of course, we would very much like to say thank you to Signe and the Defudger team for participating today. Very great presentation, very interesting stuff. And then we just would like also to do a little bit of advertising here, because the collaboration between KPMG and DTU Skylab CBS is continuing. So we will have an event on the 25th of August in the Skylab. So please mark your calendars already now. And there might even be more of these kinds of sessions before that. So thank you to Defudger, thank you to Signe, thank you to everyone who joined online. It was great having you, and have a great, wonderful continuation of your day. So thank you very much.
Thank you.
Thank you.